This is the homework helper for Chapter 5, Section 6 in the 7th grade workbook, Slope and Rates of Change. So 1 and 2 have the same directions. We're supposed to tell whether the slope is positive or negative, and then find the slope. Well, remember, there's 4 different answers you can give here actually for the first part, even though there's only 2 that are implied. Line that goes up from left to right has a positive slope. Line that goes down from left to right has a negative slope. A line that runs left to right across the page, horizontal, has a slope of 0, and a line that runs up, down, vertical across the page would have a slope that's undefined. So we're going to go ahead and take a look at question 2. Since this line points up from left to right, first answer here is that this is going to have a positive slope. Now follow-up here, the follow-up question is asking me to actually find the slope. So let's talk about finding the slope here. What you want to do are find 2 points that are on the line. Now they've actually already defined those 2 points for us. They want us to work with 0, -2, and 3, 2. When we find slope, we're going to work left to right, always, just like we read a paper or a book or anything else. Read left to right, so we're going to find the slope working left to right. What you want to do is first find the rise, how much it's going to take you to get from the point on the left to the point on the right. Now the rise could end up actually being a negative number if you have to go down to get from the point on the left to the point on the right, which is what you'll see develops as you go through question 1. But here in question 2, to go from this point to this point, the first thing I have to do is go up 1, 2, 3, 4 jumps. So my rise here is going to be 4. And again, if we go down, that would end up being a negative number. Then I have to figure out the run. The run is how much I go to the right to get to that other point. Now, truth be told, you don't always have to go to the right, but since we're always going to do the questions from left to right like we read, our run is always going to take us to the right. So the first thing what I'm going to do now rather, is figure out how much I have to move to the right to get to that point. I've already gone up to get to that point. Now I have to go right to get to that point. Well, if I make 1, 2, 3 jumps to the right, the run is 3. So my fraction here that's going to represent my slope is rise over run. That's all slope is. So when I was to say what the slope is here is 4/3. The other thing that should be true here is whatever you answer here should match with what type of number you have here. We said the slope here is positive. The numerical value also ends up being positive. If I said positive here and then I ended up calculating something over here that was negative, something would clearly be wrong. All right, let's go ahead and take a look at number 4 now. 3 and 4 have the same directions. It's saying for me to use the slope and the point to graph the line, and they've given me 1/3 and -1, -2. So what's probably confusing here, or what could be problematic for us, is that the information they've given us is actually kind of backwards. I'm not going to be able to do anything with the slope until I plot a point. So that point that they've given us there, that x, y value, the second thing they've given us, is actually what I'm going to plot first. All right, so the point that they've given us in number 4 says -1, -2. So I've got to put a dot at the point -1, -2. Well, remember, the first value represents where a point is in terms of the x-axis, the one that goes from left to right. The second one represents where the point is at in terms of the y-axis. All right, so to go to -1 on the x-axis, the one that runs left to right, go to -2 on the y-axis, the one that goes up down, pull my fingers together to where they meet. That's the point -1, -2. Okay, now I'm going to plot the slope. The slope here is read as 1/3. So slope of 1/3 means I'm going to rise 1 and run 3. Slope is always rise over run. I don't have to question it. It's always going to be that way. So in this question, the top number is 1, means I'm going to rise 1. The bottom number is 3. That means I'm going to run 3 or go to the right 3. So from this point, I'm going to go up 1 and 1, 2, 3 over. Where I land is my second point. I connect my points, and there's the graph of my line. Remember, everything here in this section, we're talking about in 3 and 4 rather, is a line. So if in 3 or 4, if you end up getting something that turns out to be a T, a U, an X, a circle, something else, you have a problem, because 3 and 4 clearly the directions say to graph the line. All right, let's go down to 5 or 6. Tell whether each graph shows a constant or a variable rate of change. Now, what you have to know here, and what you hopefully remember here, is that in order to show a constant rate of change, you have to have a slope that's the same the whole way through. Well, the only way you can even have a slope is if it's a line. All right? That's the only time the rate of change would be constant. So if it's something else, not so much. All right, so if we look at number 5, and when they're asking me to find constant or variable, let's pick some points. We don't really have to work this hard because we know what the answer is going to be. But let's say I want to go to here to here. To go from this point to this point, I have to go up 1 and right 2. So the slope there would be 1 over 2. That slope now has to be the same no matter where I look at this line. Well, let's say instead I want to look at the point I just drew, this point. So I'm going to go from here to here. Well, look what happens. I go 1, 2 up, 1, 2, 3, 4 over. So the slope there is 2 over 4. Well, what does 2 over 4 reduce to? 1 over 2. Slope is the same. Right? Let's say I want to go from these two guys, from here to here. I haven't done these two yet. I go up 1 and then 1, 2 over. 1 over 2. The slope, no matter what set of points I pick, always works out to be 1 over 2. Because the slope is the same, that shows that the graph is showing a constant rate of change. Remember, slope is a rate of change, and what they're implying here by saying constant is that the slope is always the same. Well, we just showed through 3 points, we could do more if we wanted to, that the slope always works out to be 1 over 2. So that's going to be a constant rate of change. Now if we go look at 6 on the other hand, 6 can't really do slope because it's not a line, which should be an alarm bell. But look, let's just say this was like a V shape more. From here to here, the slope would be negative because it's falling from left to right. So let's say this has a negative slope. It doesn't really have a slope at all, but let's just pretend. All right? Well, when I come over here now, all of a sudden, the line is going up from left to right. So that would have a positive slope. Well, if this is a negative and this is a positive, that's going to defeat the idea of being a constant rate of change, because this would have to be a negative number, this would have to be a positive number. That's what variable means. It's different. Right? It would be different over here than it is over here. Absolutely it is. So when we answer number 6 is going to show a variable rate of change.